Welcome to the lecture on CPLD and FPGA. So this will be the last topic of Unit 4, where you will be discussing introduction to complex PLDs. Complex PLDs are CPLD and FPGAs. So complex programmable logic device means CPLDs. So essentially they are designed by combining PALs. So many number of PALs are combined to form a single chip. That means you can realize complex functions using CPLDs because you are combining so many PALs. So all the PALs are connected through a cross point switch. So they can handle complex logic functions, and it varies according to the manufacturer. So it will not be same architecture. So architecture varies according to the manufacturer. So it's a completely theory concepts, CPLD and FPGA. In general, they are all similar, that they consist of function blocks, input-output blocks, interconnect matrix. What is a function blocks? Which are intended to realize the functions. Again, using AND gates and OR gates, or AND plane first, then followed by OR plane, which is nothing but a PAL concept or any basic combination PLDs. And multiplexers, you require selection scheme and clock or flip-flop. So it is a sequential, I can say it is a sequential PLD also, because it is consisting of flip-flop. So flip-flops are used or operated based on the clock signal. That is, you can synchronize the data transfer between CPLD and external world. So CPLD is a chip, right, by combining all the PALs to realize complex functions. So this is a typical CPLD architecture, where different functional blocks are connected through interconnect matrix. That means there would be lot many switches in this interconnect matrix, and these are the input-output buffers. That means input given to this would be stored in these buffers, then processed in the functional blocks, and then fed to the output. So at the two ends there would be IO blocks, which are nothing but input and output blocks, and FB means functional box. Actual logic operation is done in this functional blocks, right? So this is a typical CPLD architecture, where at the ends it consists of IO blocks, and in between IO block and interconnect matrix there would be function blocks. So the functional blocks are used according to the requirement. If it is a very complex function, all the functional blocks are used. If it is a simple function block, only one functional block is being activated, remaining all the functional blocks are deactivated. So I can say this is one PAL, this is another PAL, this is, so like this the functional block can be assumed as a PAL here, right? So this would be the internal architecture of a functional block. So it is very simple. It looks very complex circuit, but which consists of AND gates and OR gates, right, internally, and some of the product terms are selected. Product term select matrix would be there. This is nothing but a multiplexer, because multiplexers are used to select only one of the product term based on the requirement, right? So no need to go in detail, but just try to remember this diagram, where it consists of AND gates and OR gates, as well as a multiplexer, that is selection multiplexer, and it consists of some flip-flops like this. It is a flip-flop which will control the data transfer between IO and this particular CPLD. So whenever the clock is enabled, then only the data is transferred. When the clock is disabled, the data is not transmitted. That means you can synchronize speed of processor and this corresponding CPLD. And coming to the I/O blocks, whatever the information that is fed to the function blocks will be stored in this, and after function block is evaluated, the output is again stored in this I/O blocks. So the inputs from product terms and sum terms output would be stored in this register, right? And this register is nothing but I/O device, and this is a multiplexer, followed by there would be a flip-flop. So I/O block is used to drive the signals to the pins of the CPLD at appropriate voltage levels. So if the voltage levels are very less, this I/O buffers would be helping. Suppose during the transmission voltage is 4 volts, if the actual voltage is 5 volts, again to regain that voltage we will be using I/O blocks. And also selection scheme is there to select whether the data is to be transmitted to the pin. Pad is nothing but a pin, right? So, and whether it has to store in the register. This is the concept. And these two are the product terms and sum terms which are assumed as a function block. Right? And a flip-flop or a register is included for synchronization. That means at which time it has to be transmitted. Only when you give a clock signal. So based on the clock signal, the flip-flop will work. That means you can start or stop the corresponding information using this register or a flip-flop by using a clock signal. And the interconnect matrix. So CPLD interconnect matrix is a very large programmable switch matrix, so which allows to transfer the signal from all parts of the device to go all other parts of the device. So there is enough flexibility for this data transmission from one end of the CPLD to the extreme end of the CPLD using this interconnect matrix.